Hello, everyone. My name is Stan, and thank you for having me present a subject that's pretty much near and dear to me. Um, it's the use of open source software and approach to mitigating risk in application ecosystems. A little bit about myself. My name is Stan, of course, and I've been a full stack software engineer for well over 35 years, actually. Um, I've worked in many industries over the years, many languages, many operating systems, many frameworks, many everything. I've been there, done that, and bought the T-shirt. I currently work in our DevSecOps organization at a major healthcare insurer here in the Philadelphia area. Currently, my focus is on the use of automation and innovation to help developers produce better quality and more resilient and secure software. I'm out on LinkedIn. I welcome anybody that wants to connect to me, assuming after this presentation you'll want to connect to me. Okay, so without further ado, let's begin. So as we all know, open source software the last several years have experienced explosive growth. It's predicted that open source software, the market's going to grow within the next 6 years by 18.2%. This is according to the compound annual growth rate. And it's going to exceed in that same amount of time by $50 billion. So it's a very big industry out there, very big business. What's fueling this growth is the widespread adoption of businesses in using open source software. So it's according to a synopsis study, 93% of all companies and organizations use open source software in their applications and systems. Why is that? Well, obviously it's freely available, or most of it's freely available. Lots of reusable code out there that just about solves any problem that you can imagine. This is increasing the speed of development and delivery of applications by these companies. So obviously, businesses are turning more and more towards open source software. There are inherent risks, however, to using open source software, we're finding. The lack of industry-wide governance and oversight of this software is needed to ensure that software is actually valid. The software put out there is actually valid, that there's proper quality and security testing that's being performed, and that is adequately documented. So there's no industry-wide oversight or governance that's assuring us of those three facts, which leads to bugs, vulnerabilities, and other issues. Some of them are catastrophic, and some of them just have other issues. So everybody here might remember the Equifax data loss that happened about 4 or 5 years ago. That was due to an exploit in an open source framework, struts, that they were using. They lost millions. They're still digging out of that. I'm sure everybody has heard of the recent log4j issue, or log4shell issue. Hackers and anybody with enough experience can actually exploit certain versions of log4j to get into operating systems and cause all kinds of damage. There's intentional sabotage, repository poisoning, and software bloat. So these are all issues that open source software brings to application ecosystems. So in recent years, my company included, the focus has been on application security. Why is that important? Well, as you recall in the previous slides, 93% of all companies are making use of open source software. And it's been calculated that 84% of code bases contain at least one open source vulnerability. The average cost that a business incurs when breaches occur is roughly $4.24 million. So that's a lot of money, especially for smaller businesses struggling to make a profit. But 84% of all code bases out there contain at least one open source vulnerability. That's a lot of risk. Closer to home, in my own company, in our own repos, we have roughly 1,000 reported vulnerabilities on 398 open source components that are used in roughly 750 of our repos, with an average of 8 to 10 new vulnerabilities reported per day. So the current tooling that we, as well as other companies and businesses, are investing in their application security journeys, are exposing a lot of these issues. We need to take steps to reduce those risks. Now, let me pause here real quick. I kind of went through those slides rather quickly. So we know that the open source software ecosystem out there is kind of like the wild, wild west. Anybody can download that software, make some, create a feature branch, create a pull request, and put it back out there. It's highly unregulated. I mean, there's no governance body that's checking to make sure that the software that's being put out there is of high quality, and most of the time it's not. So we in the business world, we have to take matters in our own hands. So we have to figure out a way to reduce that risk of using open source software. It's not going away, it's only going to grow, and it makes sense to use open source software. It's reusable software that solves problems for us. We just need a way to be able to regulate its use, to control it. So before I go, any questions? Okay, let me keep going here.
Sorry. Yeah, we're good.
Okay, so how do we, as a business, as a company, as an organization, how can we regulate open source software usage in our application ecosystems? How do we, so our solution is to leverage automation to do that. All right. Many businesses and organizations are turning to automation to automate their build and deploy processes. It's called DevOps. Automation is key. Automation allows faster development and faster delivery times. It goes hand in hand with agile development. So we're going to leverage our automation to help solve this problem. So how do we solve this problem? There's a number of steps that we have to follow here. And one thing I want to note is we're actually pretty early on in this journey ourselves. We just started this basically in the beginning of last fall. So we're learning also as we're going along here. So the first step that we need to take is we have to understand, we have to know what it is we have in our ecosystem already. Prior to pipelines, CI/CD, continuous integration and deployment, prior to DevOps, developers are just building their software and putting it out there in production, in our production servers. All right, they're using Maven, they're using NPM, they're using NuGet, and they're importing dependencies with their software. And there was no checks and balances. So we have all kinds of stuff out there. So the first step that we need to take, that needs to be taken, is we need to create what is called an SBOM, or a software bill of materials. You've probably already heard this term already. An SBOM is going to answer two questions for us. It's going to tell us what components we are using, and it's going to tell us how many different versions of these components that are being used. This is very important because we can't fix what we don't know what we have. So in order to track our SBOM, we need a database, okay, or a component reference library, we're calling it. And that's basically a database reference library, a set of tables that keeps a reference or a track of all libraries and their versions that are in use by our applications in our ecosystem. Basically, this database maintains our SBOM for us, as well as for individual applications. All right, so not to confuse this reference library with what we call what is known as an artifact repository. So Maven Central, that's an artifact repository. NPM is an artifact repository. NuGet is an artifact repository, and same as PyPy. Those artifact repositories, they maintain the actual artifacts and versions, as well as other information in those repositories. But they don't do a great job at allowing you to query those repositories and to slice and dice the information that's in there so that you know exactly what you have in there. So we've created our own reference library, which is just a reference. All right, it keeps track of where the artifact came from, org Apache, Google, Microsoft, whatever. The artifact name, log4j, commons-io, commons util, so on, Spring Web. The artifact version, and along with the artifact version, the date that it was actually introduced into our ecosystem, the effective date and a termination date, and the status of where that artifact and version stands in our library. Really quickly, an artifact can have 3 possible statuses: under review, which is when it first comes in; approved, meaning that it's approved for use; or rejected, meaning you're not allowed to use that. The next step is, okay, we have to provide a window into our SBOM, into our reference library. So a web application was built for developers and decision makers, really anybody, to be able to view, update, and categorize all of that SBOM information. All right, and I will, in later slides down the road, I'll go into more detail on this, on why the web application is important in this whole thing. Okay, so the next thing on the list, that we have our SBOM database. Now we need to populate it. We need a way to populate it. So a series of web services were developed. I actually developed them for my company. I actually developed the database too. Actually almost did the whole thing, but that's another story for another day. These web services are built to be callable from any pipeline, and their capability, their functionality is they identify the build type that's coming in. So if it's a Maven build, then it's going to look for a POM file or a series of POM files, depending on how many POM files are in that repo or in that build. If it's an NPM build, it's going to look for all the package JSON files. If it's a NuGet, it's going to look for project files coming in from the .NET world. We haven't done Python yet, but that's down the road. So what these web services do is if they see it's a Maven build and they detect there's a POM file or a series of POM files, it's going to crack open those POM files. It's going to parse out all the direct dependencies in all of those in one or more POM files and their versions, and it's going to cross-reference all those direct dependencies and versions with what's in the reference library. Okay. Now, why are we looking only at direct dependencies? Well, there's 2 types of dependencies. There's direct dependencies and there's transitive dependencies. A transitive dependency is a dependency or a component that was introduced by the direct dependency. So if your direct dependency is, say, Spring Web, well, Spring Web has its own dependencies that make up Spring Web. The reason why we're only tracking direct dependencies is because those are the dependencies that our developers have control over. We don't have control over transitive dependencies. That's the maintainer that actually has control of those transitive dependencies. So we can only track and control the actual direct dependencies that our developers, are actually bringing into their applications, into their builds. So we have the SBOM inventory, the reference library database. We have a set of web services that will populate that database. Now here's where automation comes in. So what we want to do is automatically track and control every build that comes in, what direct dependencies they are using. All right. So this is an example of a CI/CD pipeline. So basically, a developer will commit code to the repository. If it's Jenkins or Azure DevOps, or any pipeline for that matter. It's going to detect that a code was committed and fire off a build, fire off some testing if there's unit testing, and then deploy. There are other things in between all that that I won't go into in this presentation. So the ideal spot to plug in these web services to track and control the dependencies that we use is right before a build. Okay, so when a developer commits code and a build and the pipeline kicks off, the first thing it does is going to execute the web services against that particular build. It's going to parse out all the direct dependencies, run it up again, cross-reference it against the actual code reference or component reference library, and then come back with statistics on each one of those dependencies, whether it's compliant or not compliant, or approved or rejected. If any one of those dependencies on the list is rejected, then the build fails and they can't go any farther until they figure out how to remediate or fix the dependencies that were rejected. All right, so that's actually down the road when everything is all set up and ready to go. So right now, we have this particular capability turned on to right now let everybody go, but automatically seed the reference library. Remember, we need to know, as I said earlier, we need to know and understand exactly what we have out there before we even enforce anything. All right, what we don't know, we can't fix. So right now, the pipeline's running for every build out there, and it's just detecting all the direct dependencies in any build that comes through, and really just populating the reference library and putting out a warning out there saying, hey, these are new libraries, take a look at it, so on and so forth. So it's the pipeline that actually maintains our SBOM for us. So that's the automation part. Any questions so far?
It's all good.
Not yet.
Okay, well, feel
All
free to
good
jump
stuff.
in. Okay, so, so
Stan,
here's
I'm sorry, I might have a question, Stan.
okay.
Do you guys consider integrating any like vulnerability detections in your pipeline there? Like there's a lot of online automated stuff which tells you where vulnerabilities are in your components.
Yes, we actually that's part of our DevSecOps pipeline. Yeah, so we invested in tools that perform static code analysis, source composition analysis, which analyzes the third-party libraries against the vulnerability database out there. Dynamic analysis, interactive analysis, and container scanning. So we have all that built into our pipeline. And we do track the vulnerabilities, okay? And that's where I said early on in the slide presentation, where we do have tools in place that are actually identifying all the vulnerabilities in all of this open source software. Problem is, we can't control the vulnerabilities out there. All we can do is we can reduce the footprint. So as you see here, as we're populating our SBOM and we're actually analyzing the data that's in our component reference library, we've realized that we have well over 2,000 Maven libraries and versions in our ecosystem. 2,000. That's just Maven. That's not including NPM or NuGet. Further analysis, we've discovered that we've got multiple components, open source libraries out there and versions that basically perform the same kind of functionality. So for instance, we have roughly 96 Java JSON, 96 different JSON parsers and versions. We don't need 96. We sure, but what that's doing is that's increasing the attack footprint. So it's introducing more vulnerabilities. As I said earlier, we have roughly 1,000 vulnerabilities found in roughly 400 of our open source components that are lurking in a roughly 700 and something repos. So we can't we don't have much control in fixing vulnerabilities out there. Actually, we don't really have the time and resources to go out there and contribute and fix those bugs. We have just too much work to do on our own here to even worry about that. I mean, we have developers that do it on the side, but we don't have the budget to be able to do that. So what we have to do is we have to use this solution to reduce the amount of libraries that we're using. So we don't need to use 2,000 Maven libraries, all right? I mean, we got 12 different versions of Spring Web. We've got 5 different versions of Apache struts. Spring Web and Apache struts basically do the same thing for you. Not to mention we have multiple versions of our own internal libraries. So that's why a solution like this, we think it's going to help reduce the number of vulnerabilities that we're bringing into our ecosystem simply by controlling the number of libraries that we're actually using. Does that make any sense?
Yeah, it's great. It answers my question, Stan. Thank you.
Okay, great. Okay, so we have our SBOM component reference library set up. We have our web services to actually parse all the builds and get all the dependencies out of the builds. And we have those web services now in our pipeline automatically populating our SBOM. So now we know what we have in our ecosystem. Now we can go in there and we can start working on that SBOM to reduce the amount of libraries that we're actually using here. But so we have to set up a series of guidelines. Call it governance. All right, we need to govern the use of open source software in our environment. So basically, these guidelines are a charter, a rules of the road, and I'll go into further detail as we go through some of these slides. But we need a governance practice to govern the use of this open software and open source software. Now that we've actually identified what we do have out there, we're going to need what I'll call a governance committee. All right, so it's basically a committee consists of subject matter experts. Security is involved, and if needed, management. The subject matter experts are those of us who know the libraries pretty well out there. Most of us have been using a lot of that software, and where I sit, I see everything that's coming into our environment. So I've got a pretty good handle of all that. So, a subject matter expert is a set of people who understand the software, understand what we do here in the company, what kind of applications we build, to be able to determine what's best to be standardized on here. Security, obviously, for vulnerability purposes, and management, normally they're the tiebreakers. So we'll usually consult our security tooling. If a component comes in, it's brand new, we have to review it. We'll look at our security tooling to see what kind of vulnerabilities are being reported against it, how critical or how severe they are. We'll look at the outside code repositories from where it came from. We'll go out to GitHub. We'll go out to Maven. We'll go out to the NPM. And try and figure out as much as we can and learn as much as we can about that software. And I'll go into more detail in a little bit. And we also will reference internal sources as well. So the governance committee is really charged with making a decision on what to standardize on, what to approve and what to reject. All right, now this is a very important step here. And this has to be done. And right now we're in the process of doing this. This is not an easy process. This is kind of lengthy. So while we're collecting all the dependencies and populating our SBOM, and everything's on the pipeline, everything's automated, and developers are getting those reports now as to what they're building with. Now that we have a big list, okay, as I mentioned earlier, we've got 2,000 different Maven artifacts and versions out there. That's just one language. Okay, that's not including the other languages that we use out there. So it's a pretty big list. It's very important that we need to drill that list down, get it down from 2,000 to some much more reasonable number. I mean, there's no reason why we need 96 Java JSON parsers and versions of that out there. There's no reason why we need to use both Spring Web and Apache struts when they basically do the same thing and have multiple versions of each out there. Remember, they're all bringing in vulnerabilities, not directly, but indirectly too. So they're transitive dependencies that are vulnerable that we can't control. We're stuck with it. We're bringing all that risk in. So this step, the research, reduce, and categorize, is very important. So that's basically, we're going through these lists and we are researching each component. We're categorizing each component. Okay, these are all Java or JSON parsers. These are all XML parsers. These are all MVC frameworks, so on and so forth. So we're in the process of identifying and eliminating duplicate functionality. That's the first thing. That's the low-hanging fruit. Anything that's got duplicate functionality, we don't need all those multiple components. Second thing we're looking at is, okay, what's the vulnerability status of these components of this source code? If we have a JSON parser that has 5 critical vulnerabilities to it, we're not going to pick that one when there's another JSON parser out there that may have either no vulnerabilities or 1 vulnerability. The thing is, as I mentioned earlier, 83% of all open source components have at least 1 vulnerability. So we're not eliminating the vulnerabilities. We can't eliminate the vulnerabilities. So we have to figure out a way to mitigate the risk and reduce the number of components, which will automatically reduce the number of vulnerabilities that we're introducing into our applications. And then finally, standardize on best fit. So if we have apps that are using Spring Web and we have apps that are using Apache struts, well, what's our best fit here? Do we standardize across the board on Spring Web, or do we stick with Apache struts? So we have to standardize on best fit. So this is a very important step. And this is probably where most of the work is going to be. And it's a one-time thing. It's a one-time effort, because once you've gotten the list down, then the pipeline and the web services and the SBOM are going to take over and manage that for us so that it doesn't get big again. One more thing I wanted to mention, going back to open source, you're going to hear a lot of people out there say, and you're going to read a lot of things out there where open source is secure. Why? Because we've got thousands and thousands of open source developers contributing to this source code, contributing, bug fixes, remediations, features. All right. Yeah, that's true. But you also have thousands of bad guys out there that are also downloading that source code, right? Analyzing that source code to find attack surfaces, just to find places that can be exploited. All right. Back in the proprietary software days, you didn't have access. Hackers didn't have access to the source code, so they had to. It was a little harder for them to figure out what to exploit. It was like a guessing game almost. But they have access to all the source code, so they can see exactly in that code where they can attack. That's how a researcher in China, no less, found the Log4Shell issue back in November or December. He was able to look at the source code and realize, wow, I can exploit this LDAP call and get right into the operating system. Not good. So vulnerabilities are always going to be out there. They're not going to go away, and there's no industry oversight. So we have to do it ourselves. Okay. So now that we have, so eventually we will have the standardized approved list of open source software components that are allowable into our application ecosystem. All right, so after the SBOM has been vetted and categorized, which was described earlier, all existing applications must be migrated to use the approved components. Again, another big step. Why? Because it's a lot of work we're asking the developers to. We're asking them now to drop what they are using and to turn and use only those open source libraries and components that have been approved. We can't do it in a big bang approach because that's going to break every build. That's going to break every build in our company. That's not good. That's counterproductive. So we're following a phased approach, basically taking a small handful of apps at a time, having them migrate. And once they've migrated, turn the gate on, meaning if right now it's let them through. The gate would mean, okay, if you have after you've migrated and you decide to bring another component, a brand new component or a brand new version in, and it's not in the reference library, then we're going to break your build. Or if it's not approved, we're going to break your build. So a phased approach is the best way to go about doing this. It eases the pain, so to speak. Okay, so once everything is in place, all the libraries, all the components are standardized in our SBOM, and we've got a solid SBOM with a limited number of open source libraries and components. Now we have to have a new component vetting process. So if any developer tries to introduce a new component, they can't just slip it in because it's got to go through the pipeline. And we have our check now inside the pipeline. So if a new component or version is automatically, okay, so any new component or version that comes in is automatically approved for a trial period. All right, if you recall earlier when I was describing some of the fields in our component reference library, there's a date introduced, there's an effective date, and there's a termination date. Okay. So for any new component that comes in, the effective date is going to be that day that it was introduced. And as of right now, it's subject to change, of course. We give them 30 days. So that means for 30 days, you're allowed to use that. Okay. But once the 30 days are up, then it's going to break until it's either rejected or approved. If it's approved, then it's approved, you're good to go. If it's rejected, then you're not allowed to use it anymore. You have to find another component to fix that problem. So when a new component or version comes in, an email automatically is sent to the governance committee, notifying that a new component or version has been detected. So right away, the committee's notified, and steps can be taken right away to do the research, the necessary research to figure out, to determine whether that component meets certain criteria, which would be. So what do we look at? Well, if a new component comes in, and these are the same questions that we're going to be asking during the research, reduce, and categorize phase that I described a couple of slides ago. So the first question we ask when we see a new component is there an approved component that already provides the same functionality that's already in our reference library? So I'll bring the JSON parser. So say we've gotten down to 2 approved sanctioned JSON parsers. Somebody comes in with a 3rd JSON parser. Okay, we're gonna do our homework. We're gonna have to see if that new JSON parser has any kind of capability that the approved ones don't have. We're going to have to do a security assessment. How many vulnerabilities does this new component have, and what are their severities? Severity is important. Could be critical, which is bad, high, which is not good either, or it could be a medium severity or a low severity, which then we're going to analyze it further with our security area. And I'm actually involved in that too, to determine, okay, what kind of risk are we incurring if we do use this component? So that's a question we have to ask. Once we get past that, we're going to see if it's actively maintained. All right. If it's Org Apache, we know it's actively maintained. If it's Google, if it's Microsoft, if it's the Linux Foundation, Any big tech firm that's really heavily into the open source world, well, we know it's going to be actively maintained. We'll know who the maintainer is. We'll also know how they view their security. And we also look at the issue history of those components. If it's somebody, like Johnny in his parents' basement that decided, that's created a component and put it out there, well, their track record's not going to be as good as a Microsoft or a Google or an Apache Foundation. And we'll scrutinize that as well. So these are some of the questions that we will ask when we're vetting a new component. Okay. Now, as with anything, we are a democracy. We're not a dictatorship. All right. So we're going to have a grievance process. So basically, this grievance process allows a developer the opportunity to plead their case in bringing in a new component, to provide us with valid reasons as to why they should be allowed to use this new component, which we may have rejected. I mean, we don't know everything. So we give the opportunity for the developer who may know more about that component to present reasons as to why we should be allowed to use that component. And you never know. That new component can replace one of the existing components that we approve because this component may be better. So there's a grievance process built in.
Yeah, it usually comes down for the developer to what's worse, migrating or proving that it's worth using. And so, I mean, it's good that the grievance process, I think that's a very good idea because it doesn't force the developer's hands, but I don't expect many developers to actually go through the trouble of trying to justify why they're using the rejected component.
Well, you'd actually be surprised.
Oh, really?
You've got a lot of developers that are very passionate about certain technologies. It's almost religious. So this is usually a grievance process. We go through the same kind of grievance process for vulnerabilities. It's just constant. Okay, so we've got everything up and running. Last thing that we need to do is developer education and awareness. Okay, that's very important as well. Studies have shown that really developers make not so good decisions or choices 69% of the time when selecting and updating open source components. They just don't make the best decisions. They usually follow the crowd. Oh well, if this guy is using it, it must be good. You know what I mean? They don't do their own homework sometimes. So this was a study done. 69% of the time, the selection and updating of open source components is not really that good. So developers, they need to be taught to focus more attention to what software they're using and to ensure that their build configurations are always kept up to date. So I'll give you an example. I went to a repository recently because of some vulnerabilities that were, sending off alarm signals to us. So this one web application, I looked in their POM file. They had well over 600 direct dependencies in there. Most of them with duplicate capabilities. They had struts in there, different versions of struts in there. They had Spring Web in there, different versions of Spring Web. They had 5 different templating libraries, Java templating libraries. That's crazy. Okay, and so you know what happens as you're developing, and I've been guilty of this too in my time. When you've got a new application or a new feature that you need to get out the door as quickly as possible, and in today's age, you got to get everything out there rapidly. Well, what you're doing is you're trying all kinds of different libraries that you come across to see if it solves your problem. So what you're doing, you're adding it into your configuration. You're adding it into your POM file. You may be adding it into your your package JSON file, so on and so forth, until you find the right one. So after you found the right one, very rarely do the developers go back and clean up the mess. So they still, they're using not only the right one, but every other one they tried. It's all going into the build. So what's happening is a couple of things. All right. That's more libraries out there, which makes the application more bloated, and it increases the attack surface. You may not be using it, but it's still out there, which means it's hackable. So developers need to be taught to focus more attention on making sure that they're looking at their build systems. They're looking at their build configurations, that they're only using that the only thing that should be in there is exactly what they're using and nothing more, because these other libraries also, as I mentioned earlier, they bring in their own transitive dependencies. So if you look at a Maven dependency tree of some of these things, it'd be a mile long. We're hoping, not hoping, we're banking on the fact that, you know, the web front end that we have built to provide a window into the reference library. We're training developers, our development staff, to always consult our reference library to find software that's sanctioned for use, as well as the latest versions available before looking outside. We're training them to do that. Once they get into the habit of doing that, then they're less likely to go outside for other components. They'll always be using our sanctioned components. And at the end of the day, what that's going to do is it's going to reduce the number of vulnerabilities, the number of issues that we have out there, and it's going to make our applications a lot better quality, a lot more resilient, a lot less hackable. Okay, future capabilities. The key word is more automation. We want to use more automation. We want to automatically detect new versions of software that's out there. We want to proactively track vulnerabilities. So we want the latest and greatest vulnerabilities to be reported on these components that we have in our reference library. We want to automate, if possible, how to remind developers to clean up their build configurations, as I mentioned earlier. So two key words here is more automation. That's our future. Our future capabilities is more automation, more hands-off. I'll say artificial intelligence. I don't like to use that loosely, because I know a lot of people out there just use artificial intelligence. They just throw that term out there for everything. But we want to build some kind of intelligence into our process here, into our automated process, to be smarter, to ensure that our SBOM is smart, is a place that we know is going to be accurate and always being kept up to date. We want to remind developers proactively that, hey, a new version of this component came out there. You need to upgrade to it. And you know what? Going back to the Equifax disaster a few slides ago, do you realize what happened? So Equifax was using Apache Struts as their model view controller framework. The version of Apache Struts that they were using at the time had a vulnerability in their file upload that allowed hackers to get into their system and steal all that data. There was an upgrade patch to Struts that they never went to. And look what happens. Developers need, we don't go out there manually and always look for updated versions. We have to be reminded. Our security tooling reminds us, but it only reminds us from a vulnerability perspective. What we need to do is we need to automatically be reminded constantly. Hey, there's a later version of Spring Web out there. There's a later version of whatever out there. You need to go to it. Why? Because the later the software, the more likely it's going to be patched. It's going to have less vulnerabilities. Our information security department, they require as best as possible to maintain an N-2 versioning of all software that we're using. In other words, don't go any farther back than 2 versions. So this process, this entire automation process for the managing open source software is going to help us get there. Okay, before I go into the next topic, any questions? Any feedback? Anything?
Well, Stan, I have some the questions, but comments, but I think I will leave them at the end if you want.
Okay.
I will let you finish. I will let you finish.
All right.
All
So
good.
I'm sorry.
I said it's all good. It's very clear.
Okay. So the final section of this presentation, topics for research. As Hafed explained in the very beginning in the introduction, I'm a practitioner. I've been a practitioner for a long time. I've done everything I could in my field and where what I've been doing, and that's why I like to get maybe dip my hands in actual research. So here's some topics for research anyway that may be of interest. All right. So the first topic is, as I mentioned earlier, the open source software industry is a very unregulated industry. There's no oversight, no governance. Anybody can put anything out there and it's not checked. This might be pie in the sky, but I'm going to put it out there anyway. I think the open source software industry needs some sort of a industry-wide certification process. All right. It's needed to ensure that the software that's being put out there has been validated. All right. We got hackers that are doing what is called repository poisoning, meaning they're taking perfectly normal libraries out there and then creating bad ones, exploiter ones that have very, very, very similar names to the good libraries, and developers are, inadvertently importing those bad libraries and not really paying close attention to the name, and they're importing the bad libraries in their ecosystems. We need proof of quality and security testing. There wouldn't be as many bugs and vulnerabilities if there was some kind of proof of quality and security testing that is out there. Right now, we can go out to GitHub and look at any repository out there. We'll see unit testing, but how do we know that regression, smoke, and security testing are being performed on this stuff? Adequate documentation. I mean, there's sometimes what you see is a README, or the documentation is not complete or very, very minimal. All right. So what happens is you download that software, you download that inadequate documentation, it forces you to learn what that software is supposed to do, and you can be introducing bugs because you may not be using that software the way it was intended to be used because it's not really documented correctly. And of course, assurances that the software performs as intended. I mean, that's important. We don't want to download any kind of software that we have no idea that it's been, that it's going to perform the way it was intended to perform. So again, this might be pie in the sky, but I just put it out there as a possible topic. The next thing, here's something. So societal forces that drive software adoption. Okay, so how many times have you gone out to GitHub and you've looked at how many stars a repository had to know if it was a good one to use, or, hey, this is the way I want to go because it's got, 500 stars. Well, those 500 stars don't mean anything. It could be a bunch of people out there just, putting the stars out there saying, let's make this thing look really good so that it's used. So the effects of social coding, Stack Overflow. How many times you've gone out to Stack Overflow for, to see if anybody solved your problem for you? What you come up with is 50 different ways, of which, 45 of them are terrible, right? and you could be downloading or copy and pasting insecure code into your environment from there. Yeah, so popularity, number of users or followers, links, and a host of other types of social information that has an impact or has some kind of control over what technology decisions, particularly libraries and frameworks. I look at the JavaScript world. How many JavaScript frameworks are out there? Hundreds of them. I mean, how do you know, that you're picking them because they're the best ones for you, or because that's what people tell you, or that's what's being written out there? So that should be an interesting topic for research. All right, better tooling to detect unused libraries and applications. Again, going back to the slide where I said developers, and I'm guilty of it too, importing all kinds of libraries in just to figure out which one works best for the feature you're trying to build or the application you're trying to build, and then not remembering or not going back and cleaning up the mess. So instead of not only keeping the good library that you wanted, but you've got the 10 others in there that you tried out, but you never removed. There are some tools that do this. I think Maven has, as part of the Maven command line tool, you can do this. I'm not sure about the other languages though, but we need better tooling that could scan and identify libraries that are not referenced in the application. All right, automatically do that and know that, and be assured, be confident that the libraries that the scanning that the tool identified, you can remove and not have to worry about it, because it's going to reduce the attack footprint. It's going to reduce the number of vulnerabilities and make the application better quality. And finally, this one is near and dear to my heart. I'm not a huge framework fan. I think the Spring framework is probably one of the most bloated frameworks that you're ever going to see out there. And that goes with tons of other frameworks. Angular on the front end, that's too big, too much stuff in there, too bloated. Why is that? Well, another thing with open source software is, there's a lot of collaboration in open source software out there. So you can have 100 developers cloning a repository and adding features. They're just adding features. They're adding features. All right. There's no one entity that's going to say, wait a minute, let's put the brakes on this. No, that's not what we want to do. You know what I mean? To limit the number of features, which will limit the amount of bloat. Look at how Linux is still developed, the operating system. So you've got tons of Linux contributors out there, but you've got one guy who has control, and the guy that says yes or no. And he's very firm, by the way. Linus Torvalds, you've all heard of him, right? He still has an iron fist on the Linux kernel and what is allowed to go in it and what's not allowed to go in it. Most open source software doesn't have that, especially frameworks. So yeah, they're often bloated, very bloated. No process to control or the type or number of features that are being added. That's due to the way open source works out there. More functionality means a bigger attack surface. So let's take Spring Web. All right, you import Spring Web, the Spring Web jar, we'll say, whatever version. That Spring Web jar is going to bring in a boatload of transitive dependencies along with it. So you got a lot of baggage. I call it the banana gorilla jungle syndrome. And Hafed, I'm sorry, because of my laptop problems this morning, I couldn't get the gorilla in there. So think about it. If you just want the banana, with most of these frameworks, not only you get the banana, but you're forced to also take the gorilla holding the banana and the entire jungle that the gorilla holding the banana lives in just for that banana. Okay, that's a lot of attack surface. So we need some way, and it may be a better way to develop frameworks. Not sure how, but I know there is a way. It has to be to disable components and functions that may not be used. So if I'm using Spring Boot, And I know Spring Boot brings in a ton of a whole bunch of stuff, but I only want to use a certain part of Spring Boot. I should be able to turn off everything else and be confident that what I turn off does not wind up in my build, does not wind up out there with my application. That's it. Now it's time for questions and answers. I hope that everybody enjoyed this presentation. I thank you all for the opportunity to present this to you. And so
thank you very much, Stan. This was a very clear presentation. There are questions, so Abdel, I'll let you speak in a couple of in a minute or so. So
thank you. Yeah.
What I want to say is I want my colleagues, the researchers, to really focus on those research questions.
Okay.
And think of ways to address them. So if you know of a solution that exists, mention it, or we can use the remaining 20 so minutes to brainstorm and think of how you would do that. And then after this conversation, we will I will circle back with Stan and see how we can make best use of this presentation, because for me, this is not a normal presentation where somebody comes, makes presentation, you ask questions, either to get clarifications or to sound smart, and then they go and then you forget about it and then move on to the next thing. So Stan came up with real problems, and I want us collectively to try, at least in the next 20 minutes, to think of how you would go about solving the problems, shooting some ideas out, and then there will be a follow-up. So, okay, Abdel, vas-y.
Yeah, thank you, Stan. Very interesting. You remember me years of developers. So I used Maven Struts in its first version, and in the second version, which is based in the web work model view controller. I don't know if you remember Hudson, the predecessor of Jenkins, etc. So thank you for your automation tool. I think it's very interesting. For the moment, as I understand, you support only Spring Web and Struts, MVC. How do you deal with the client-side libraries like Angular, which are model view controller?
Yeah, so our technology.
Do you support them? Do you support them? Do you support client-side MVC implementations?
No, we don't. We've settled on Angular, but we don't use the full model view controller concept of Angular. It's more just a front end presentation kind of thing.
Okay, and I think I had another question. Yeah, well, I don't agree with you when you said there is new version, get it, because I remember. I don't know if you know. I'm sure you know Hibernate as persistent API, and we did. I think there is a first version, and there is a minor change in the first version. We get it, but they changed the default value. I don't remember if you know the lazy attribute that loads that add joins, and we took it, and after that it was a disaster. So I think yes, there is a minor version, or there is a new version, or there is new upgrade, etc. So I don't agree that we should take it, or I think there is a quality assurance work to do before, and before taking these like decisions, because I know that this minor version caused a lot of problems even at IBM USA, because they take it, and after that they found that the default value has been changed to the opposite, and they did the opposite, and there were a lot of performance problem related to that. Do you agree?
Yeah, yeah, and we take it on a case by case basis as to where to go or what versions to go, and that's actually a topic of discussion that's ongoing in my company. You mentioned Hibernate. I'm not a big fan of Hibernate. I've seen literally five failed Hibernate projects. It seems like the larger the database structure, the less effective Hibernate is. Our average database number of tables here is, well over 400 to 500 tables. You throw Hibernate against all those tables, especially on a normalized database, and it degrades very quickly. So we're not very big Hibernate fans around here, just based on what we've experienced with it.
Yeah. So thank you. Well, I think I had another question, but
Abdul,
I
maybe in
looking for that.
second round. I want to get everybody.
Yeah. But that's okay. You can go ahead. I must leave at 2. So I think that he can. If you can put the presentation in the website.
Yeah.
So I can see the research area you wanted to look at.
Chris.
Hi, thanks, Stan. Really enjoyed your talk. I am responsible for teaching the frameworks, or one of the courses where the students use frameworks in NPM with Node. And we have a skeleton for our code that we try to update every semester. And I have lived this project problem of attack vulnerabilities and dependencies and things that go and things that got added really quickly. So I really understand, at least from that standpoint. I'm not working in industry, but I'm understanding the evolution, the maintenance problems that it creates. I just had more of a comment than a question. I think my comment was, one of the things I realized was that we have our developers on this thing, or sort of like lab assistants, the people that help me maintain the code, they're using IDEs, and the IDEs are constantly proposing these quick fixes to solutions with plugging in this library and making this thing work. And it's so great when you're a developer, just click yes, I'll include this plugin, I'll include this thing, my code works. All of a sudden it's working so fast. But of course you don't know the 6 months down the road what's the consequence of those short-term fixes. So, and you also mentioned that your build process, your governance or your checking process comes right during the build. And it seems like that's almost too late, because I almost think it should be at the IDE level. It's the minute that I want to put this library into my include, or I want to include this thing in my code, it seems like that's the moment where you want to make sure it's okay, right? Not when it's building, because maybe the official build is kind of late, but at least maybe earlier during the IDE process. So that was my comment, is involving the IDE step.
And I agree. As a matter of fact, that's our security posture. Shift to the right, shift to the left. Basically, so okay, our security tools currently we use SonarQube for our static analysis. We use Nexus IQ for our source composition analysis. Both of those tools have plugins for Eclipse, extensions for both Visual Studio as well as VS Code. Not sure what they have in the Python world or not, where the developers can see right away, what libraries they're using, if they're vulnerable or not, or if their code is vulnerable. So for us to be able to do that with our process, remember our process, we're not a vulnerability tool. What we want to do is we want to limit, we want to control what libraries, what open source software they're bringing in. So we would have to build a plugin for Eclipse that is going to work for every version of Eclipse that is out there. We're gonna have to build an extension that's going to work both in VS Code and Visual Studio. As I mentioned earlier, we're very early on in this process. We started this basically beginning of last fall, I guess, and it's really ratcheting up now. And I can see that as definitely the better tooling, of being able to produce a tool like that. That tool is going to have to connect to our reference library database. So, it'll be kind of proprietary to us because it's our database. But I can see definitely down the road where something like that could be very helpful for other environments, as long as they have that database to front it or to be behind it. So that's a good idea, and it does go along with the concept of a shifting to the left. Get it before the developer even commits his code. But for now, we're adding this right before the build on our pipeline, which means as soon as code is committed, whether it's on the Jenkins pipeline or Azure DevOps pipeline, we've got two main pipelines right now, and we'll have more. We're going to have Google GCP's pipeline, AWS's pipeline. Yeah, we're going to have those two as well. So we want to hit it. Yeah, right now, right out the door, we're hitting it right before the build happens. Which is close enough for now. Our main goal, no matter what, is we've got to control these libraries. We have to control this open source because it's not being controlled out there. All right. We got to get those 2,000 Maven libraries and versions down to something much smaller than that. All right. So that instead of having 1,000 vulnerabilities on all those components, we can cut it down to 200 vulnerabilities. And that's going to improve the quality of our software. All right. It's going to protect our data. I mean, really, when you look at vulnerability protection, we're protecting our data. The hackers want our data. They don't care about our applications. They're just using our applications to get to the data. So any way we can reduce that risk in our applications, and this is just one solution that we came up with. And as with any solution, it's going to evolve and it's going to get better into things like you said, getting it into the IDEs. So yeah, it's a great suggestion. And I think it fits right in with that better tooling thing. Thank you.
Great, Noel.
Yes, thanks for the presentation. It's really interesting. And actually, because we start to work on this subject, there is one of my PhD students who is attending right now the seminar, Osin. So Osin is interested in identifying vulnerabilities by mining software updates, commits, pull requests to prevent attacks on what is called the software supply chain. So combination of software using open source libraries. And regarding the question you listed in your slide about the governance, we recently performed a large empirical study on dependency updates and security pull requests using the tool Dependabot, which is a dependency management tool on GitHub. So we were able to identify who are maintaining, what is the history of the different libraries, the patches. Maybe Osin can explain more in detail what he has done, but definitely it's a subject of interest for us. If you don't mind, may I just, Osin, please.
Yes, of course. Well, first of all, let me say thank you for the presentation. It was really interesting. I'll start by presenting myself. My name is Hussein Rabachi. I am a PhD student. I start last year in winter 2021. As Dr. Nawal mentioned, my thesis project is about mining software updates to prevent software supply chain attack. So the end goal is try to use what's called deep representation learning in order to detect these vulnerabilities, detect the different attack patterns that were not detected before. And concerning the work that we have done, we were trying to look into the pull requests that are created on GitHub by developers and also by a dependency management tool called Dependabot in order to understand certain aspects. We found some interesting findings concerning, for example, the time that these vulnerabilities remain undetected in these projects, and also the different practices and the ways that developers try to mitigate or eliminate these threats and dependencies. So I had actually a few questions and maybe some suggestions, since you've mentioned in one of the research proposals talking about how to remain updated or how to remain that certain consciousness about the new versions. So for example, there are certain automated dependency management tools, for example, Dependabot. There's also tools called Sneak, there is Renovate, Greenkeeper. I was wondering if you have actually considered using these tools.
We do. I'm glad, great question. I'm glad you asked. So right now, our tooling for our static analysis, we're using SonarQube. That the static analysis tool that analyzes our own source code for bugs and vulnerabilities. We use a tool called Nexus IQ by Sonatype. And Nexus IQ is the source composition analysis tool where it goes in and reports on all the open source libraries, what is vulnerable, what's not vulnerable. So Nexus IQ is that tool for us. We have other tools, as I mentioned earlier, container scanning and Prisma we use for that. DAST, dynamic scanning, we use HCL app scan. We are currently in the process of reevaluating all of our security tools. So coincidentally, the last 2 months now, we've had several rounds of demos and talks with all the major vendors. So we've had Sneak in here recently. We've had Veracode, Synopsys, Checkmarks, HCL AppScan. There was one other. So yeah, we are in, I know all about their tooling. I've seen all the demos, the dog and pony.
The good thing to mention is that the way that the detection is performed is that based on a certain reference, because I believe you mentioned you having a reference library or have all these components. So they try to extract this information from the GitHub advisory database, for example, or the NVD following the CVE standard. So these are basically vulnerabilities that were detected by security experts, and it's something that was validated.
Right.
And so I was also wondering, when you mentioned about adding these components into the library, you've mentioned the component being approved or non-approved. So how does this, how is it approved basically, and who approves the component? Is it a manual process that is performed by an expert?
Yeah, in the presentation, part of the governance.
Sorry, I just want to give a chance to Rizlan to ask your question, but Stan, if you don't mind, he went over the governance section. I don't know if you saw that part, but he went over.
Yes, I've seen that part. So the governance is basically the purpose of governance is to approve these components before adding it. I thought there was something to be done after. So yeah, that's
the subject matter experts who look at this.
Yeah, we'll go. The governance committee goes through all of these different components.
So I want to give a chance to everybody to ask a question. So Rizlan.
Thank you. I didn't want to interrupt Hussein. Sorry. Thank you, Stan. Very interesting talk from the practical perspective that you have. I was just wondering if you have any ideas or practically what do you do inside the company to compare frameworks? In some research projects, we try to compare different frameworks targeting the same, let's say, domain or functions. But it's not that obvious. It's really difficult to come up with some, at the end, with some rating or some, I'm thinking, for instance, about what you mentioned as an example is a very good example, JavaScript frameworks. It's really hard to do, I don't know, make way in the jungle. There is a jungle there, and we tried with some students, but really I'm not confident what we did is worth sharing. We went by different criteria, but it's still very academic, and it lacks some practical perspective. And at the end, as you said, some developers are just it's like a religion. They just want React or Angular or whatever. So I'm really interested in this aspect, factor recovery, because it's a recurrent issue in different domains that we have.
Yeah, so let's take Angular, for instance. So somewhere along the line, Angular showed up in my company. Somebody brought it in. It was pioneer. They worshipped it. They said, this is the greatest thing since the wheel. We have to use it. All of a sudden, all the developers are using it. Problem is, nobody asked that question. Why? Why did you pick Angular? Okay. Sometimes, well, Google created Angular. Google's the one that maintains Angular. So if Google did it, then it must be great. Well, these companies, these high-tech companies, whether it's Google with Angular, Facebook with React, so on and so forth, they'll create those frameworks for their own needs. All right. And then what happens is, hey, you know what? Hey, let's put it out there and get everybody else to use it. It's kind of like a who's best kind of thing out there. All right.
Yeah.
That's where the whole societal thing comes in. Why we get influenced, in our choices in just about everything. And that includes software, frameworks. Now for me, I've used a lot of them, and I always reserve judgment after I've used them, after I've had to use them and after I've, my trials and tribulations with them. So you take Angular, for instance. It's amazing how long some of the builds take to build an Angular front end, all right, on the pipeline. It's amazing. And all the components that are being brought in, I'm like, do you need all this? Because at the end of the day, on a browser, it's JavaScript, HTML, and CSS at the end of the day. You've got all this stuff coming in, and it's overwhelming. And most of the developers, they'll jump on that wagon, not fully understanding how to use that framework. So we field all kinds of questions. My build broke. Yeah, okay. Well, what do you want us to do? Look at it and fix it for you? You chose this framework. You go in and fix it. You know what I mean? So it's as I said earlier, it's a religious thing. Everything in software is a religious thing. Some people swear by Eclipse. Some people swear by the other browser. I forget what it's called. Some people swear by VS Code. Yeah, and same with frameworks and libraries. Yeah, and that's how they gain traction out there. Until you get hundreds of them that do the same thing, and you don't know what to choose. The other thing with frameworks is they come and go. So if you put all your eggs in a framework basket, and all of a sudden support stops, right?
Yeah.
And it's on to the next big thing. All of a sudden you've got all this technical debt. Now you got to take everything you built in that framework and rebuild it in something else. That's time and money that most places don't have. And also, let's take Angular. So Angular JS, when that came out several years ago, everybody jumped on the Angular JS bandwagon. And then Google turned around and they went ahead and they totally rewrote Angular JS into Angular 2.0, which was not backwards compatible, which forced everybody that used Angular JS to basically rewrite their code so that it would work with Angular, 2.0. Yeah. That's a lot of wasted time and cost that companies just don't have. And you're spending, and the other thing is you're spending a lot of time with these frameworks. Okay, so a framework will give you 90%. Well, I'll just throw this out there. It'll give you 90% of what you're going to need, right? Mm-hmm. Oh, look, you don't have to write all this boilerplate. Okay, we'll do that for you. But it's that other 10% is where you spend most of your time pulling your hair out, trying to get it to work, trying to bend the framework to get it to work. Then you got to put all these different hooks in there, and that's where it all gets out of whack. So, there's pros and cons. In my years of using frameworks, and that's a lot of years and a lot of frameworks, I've come to realize that I don't need them as much as other people seem to need them. I just don't get it.
Yeah, that's because you are
imagine,
from
I'm a kid.
Hafid's generation.
You know, and they come from
We
In
may
my
be getting
generation
older,
also.
but we're wisening up.
Because you know, all undergrad students who are, I don't know, maybe 22 years and less, they just live by frameworks. They
Yeah,
jump
I mean,
on
you know,
Angular, React, or whatever, and they
yeah,
don't
they don't
even know what their code is.
They want to put it on their
I don't
CV.
know, 50% of the code
yeah,
is
yeah, well,
out
that's
of
what
the
it is.
reach.
You don't know Angular, and if you're a kid coming out of college, and I've interviewed hundreds of them where I'm at, hundreds of them. If you don't have that, I mean, if you want a job somewhere, you better have you have to learn it. You know, I'm at a point in my career where I don't have to learn it. You know, I don't. You know, I'm glad because I don't want to learn that stuff. I mean, I know it. I've used it. I have to know it in order to, you know, to do what I do with my job. That doesn't
I'm
mean I
learning
like
it right now, actually.
Yeah.
If I share my screen, I will show you some React. So I'm going to have to wrap this up. Stan, thank you very much. This was very interesting. We reached the 2 o'clock time stamp. But if you allow me, I'll just finish with this anecdote. So some of my colleagues know how I feel about research and software engineering. And so I think that to be able to continue doing research in software engineering, I need to have the development skills of my bachelor students, which I think is not asking too much. So one of them is, you know, pick a JavaScript front-end framework. So I asked a couple of colleagues what they thought of, you know, Vue versus Angular versus React. So, so one of my colleagues, who's even older than me, and who had his hands in the pie until 2 years ago, he's over 70. He said it's all crap. So,
I'm on board with him.
Okay, so I asked him, "Can you elaborate?" Like, okay, good. Can you elaborate? So he sent me a hyperlink to a blog by somebody who said why they're all crap. And my first question is the first question that came to my mind, which is the same question I ask my son when he reads something on, or when he listens to something on YouTube. Who is this guy that I should trust with opinion on such package or such package? Because you can choose whatever you want. You'll always find somebody who agrees with you. So I say, why do you like Vue? Oh, I like Vue because this and this and that. And here is a blog entry where somebody says why Vue is far superior to React and Angular. So I think it's a very interesting and very tricky problem. The social context of how we get influenced, and for me, that's a very is for somebody like me who comes with no preconceived ideas. I'm not going to be making a living, coding the front ends. I just want to see what developers live through, to think of ways for them to facilitate the development. And I can't find any opinion that I can trust, because I will find all opinions and I don't know whom to trust. So I think that that's for me, that's a very interesting research topic.
Well, there's a ton of opinions out there, and you just hit the nail on the head with your son looking at YouTube. That's a perfect example of societal forces trying to influence an opinion. It's trying to influence something. You mentioned Vue. One of the things, one of the topics that has always interested me is the history of a particular software component. So the developer of Vue, the main creator of Vue, came from the Angular team. Okay. Got disenchanted with the direction Angular was going in and decided to create his own framework, and he called it Vue, which is kind of a watered down, a little bit of a better version than Angular. I mean, if I had the choice of Angular and Vue, I would go with Vue. But that's just my own opinion if I were to go in that route. React is a library. It's not even a framework. People call it a framework, but it's really a library. And the funny thing is, the head of the Angular development team at Google jumped ship 2 years ago and went to the React team at Facebook. So, if you know I'm always particularly interested in the history of a certain piece of software. Let's take Log4j. All right. The original creator of Log4j quit the Log4j team because he didn't like the direction they were going in at the time and went ahead and created Logback and Log S4j or something like that. All right. So you got to wonder, okay, why, what direction were they going in that caused this person who created Log4j in the first place to leave? All right. Then you look at Log4Shell and the fact that a researcher was able to exploit LDAP calls that were built into Log4j, to get into an operating system and cause all kinds of problems. Well, you think, okay, so you're thinking, okay, so Log4j was developed to be a logger, a Java logger. Why? Because back in the early 2000s and the early versions of Java, the logger wasn't that good. So how does a logger go from being just a logger to logging information in a log to providing LDAP search calls? Okay, that's going away from the original intent of that software. All right, that's where open source can go wrong, as you see. So for me, the evolution of a piece of software, I'm always interested in. I'm always digging into a component or a library that I might be interested in and trying to go into its history from birth till what it is now and learn all I can about what that thing, what it was doing, what it's been doing, what issues, who's maintaining it, all that, to get a good knowledge of what that piece of software is going to do for me, including vulnerabilities. And getting back to one of the PhD students, and all yous are PhDs. I'm kind of intimidated here. I'm not a PhD.
Right. For this topic, you are the most knowledgeable person here, so don't worry about it.
All of these source.
I have sorry. Sorry. I have one point. I use Angular. I use more server-side model view control implementation like struts, webwork, etc. And I use recently used Angular. I think Angular is very efficient when you design using what we call the SPA single page application. Yeah. Which means that it's a model view controller, but it's a single page, and a lot of banks are doing that. So there is a lot of XML links, so one page, and so a lot of JavaScript based on Angular. I think this is a use case when we can use Angular and it's efficient. Otherwise, I share with you your opinion that server side is it's more.
Okay.
More.
So we'll keep that for another discussion.
Yeah, exactly.
We'll wrap it up for today. So thank you very much. I will stop